This video is about vectors and scalars and also contact and non-contact forces. So the learning objectives are to know the difference between a scalar and a vector quantity, be able to identify scalar and vector quantities used in physics, in particular in forces, know the difference between speed and velocity, be able to identify contact and non-contact forces, and understand what is meant by a balanced and unbalanced force. Quickly check the spec. Tells you that scalar quantities have magnitude only, vector quantities have magnitude and associated direction. A vector quantity may be represented by an arrow, where the length of the arrow represents the magnitude and the direction of the arrow, the direction of the vector quantity. There'll be examples of this. There are 12 quantities here used in forces. I'm just going to talk through whether they're scalar or vector. So number one, mass is a scalar quantity because you cannot have a direction. It is just got size only. And also you can't have a minus mass. Number two is distance. Is a scalar, whereas the equivalent vector quantity is displacement. So distance is how far you can travel in no particular direction, whereas displacement is how far you've traveled in a particular direction, how far you've been displaced. Speed is a scalar quantity of how fast you travel, whereas velocity is used as a vector quantity. That's how fast you travel in a particular direction. Energy is just got size, it's scalar quantity. Time has just got size, scalar, and aid also is a scalar quantity, just having size. Momentum, which we'll come on to later, because it relates to velocity of an object, then because velocity is included, it must be a vector too. It must have direction. Current also, when you studied electricity, you know can have direction because it can go in two different ways. It can have a plus and a minus sign, if you like, and so can forces. And acceleration is the last one we'll come on to later, which is a vector quantity. Let's have a look at two pairs, if you like, scalar and vector. Speed and velocity. Speed is simply how fast you're traveling, whereas velocity is how fast you're traveling in a particular direction, the speed in a direction. So this car, you could say, is traveling at a speed of 20 meters per second, but if you want to describe its velocity, you will add the direction. We don't always say northeast, west, south. In physics, we normally have a plus going one way and a minus going the other way. Okay, the second half is about contact and non-contact forces. This is quite straightforward. It is what it says it is. Contact forces are objects that are physically touching each other, whereas non-contact forces, they're not being contact, they are physically separated. So just remember the examples below. Probably worth writing these down. Friction, air resistance, tension, and normal contact force, which we'll come to later, are all contact forces, whereas gravitational, electrostatic, and magnetic do not make contact. They can act at a distance, so they are non-contact forces. Remember, in forces vector quantity, you should be able to describe the interaction between pairs of forces, which we're going to come on to. So let's have a look at balanced and unbalanced forces. This is Newton's first law, and we'll come back to this in a future video. Isaac Newton said that basically a body will remain at rest or continue to move with a constant velocity as long as the forces acting on it are balanced. That means they cancel each other out. And therefore, this car, when it's stationary, has no unbalanced force. The forces are balanced, so it will not move. Okay? But if it is already moving, then it will continue at a constant velocity. It will not slow down or speed up unless there's an unbalanced force. For example, air resistance or friction is bigger than the driving force. So let's have a quick look to finish this off to make sure you're understanding what will these cars do and why. Well, this car, let's just draw the four cars here with the forces represented by the arrows. So the first one, there's an unbalanced force that will accelerate forwards, i.e. towards the right. The second one will also, okay, that's one that's going, the force going to the left there is probably air resistance or friction, so it will still be accelerating. Whereas the third one, when it's traveling at a steady speed, the forces are balanced. So if this car reaches its maximum speed, when the driver has foot right down on the accelerator, it'll not go any faster because the acceleration force, the forward force, is balanced by the air resistance and friction force, trying to slow it down. In the last one, the person has taken the foot off the accelerator, if you like, may have applied the brakes as well. These are unbalanced forces, so it will slow down and eventually come to a halt where the forces will be balanced again. Just a reminder, all my videos are not only on the Learn Physics SharePoint site, but also on my Learn Physics YouTube channel, so you can see the full playlist here. Two short videos from Fuse School which are worth watching. This 2.5-minute one here, Forces That Can Cause Change. And another 2.5-minute video on balanced and unbalanced forces to help you with your understanding of these concepts. Thank you for listening.